Welcome to a new video for Chapter 3, Section 5. For this section, you need to get your graphing calculator, or you need to open your emulator on your phone or other device, but you need your graphing calculator emulator to do this. You need your textbook, and you need to open to page 132. I'm going to tell you some things to copy down. So on page 132, we're talking about systems of nonlinear equations. Copy down those pictures on page 132. You need to pause the video to do that. Make sure you understand this concept. We are finding where the two equations intersect. We are finding where the two equations intersect. And to do that, we're going to go to our calculator. We're going to type in second trace, intersect, hit enter when it tells us to identify the first curve, hit enter when it tells us to identify the second curve, and then move our cursor right or left to take a guess. If you need to pause and rewind that so that you hear me and have the chance to write this down again, or more chance to write this down, do so. The examples in the book are very good. Go to the Student Dynamic ebook and play them in addition to what I'm going to do. We are on the bottom of page 133. We definitely and we always need to copy down the questions of what we're doing. So it does say to solve using any method. I'm telling you I want you to graph. This is what I want you to practice. So in our graphing calculator, turn it on. Now remember, at any time you need to pause. You should pause this video. We're going to type in the first equation to y1. So remember to go to y equals. Make sure you press the correct negative sign. Press the down button to get to y2. Type in the second equation. Okay. And we have to press graph. Make sure you write those instructions down. Those are for your notes. Okay. So I see that we have a line and an upside down parabola. Awesome. Find out, let's see if they intersect. Second trace. Intersect is number 5. This is the first curve graph that we typed in. So we hit enter. Now it automatically takes us to the second curve. Notice it goes to the y-intercepts, which is great. So this is the second thing we typed in. We hit enter. Now it wants us to take a guess. So I'm going to move to my right. And I think it intersects right around here. It's a guess. We hit enter. So it turns out, oh, this is some bad calculator math. All right. It turns out for number 1, it intersects at, what are you really going to round that to? You're going to round it to the number 2, right? 1.9 repeating is 2. Remember, your calculators aren't smart. They're just doing what they're told. This is scientific notation for times 10 to the negative 7. And you remember that means bring your decimal point and move it 7 spaces this way, filling in zeros as you go. All right, so we have 0 point, a lot of zeros, 3, blah, blah, blah. It's your calculator's way of rounding to 0. You need to remember, you're going to see this a lot. This e to the negative 7, that basically means 0. So our answer is 2, 0. We write down the whole coordinate. Okay, we write down the x and the y as a coordinate pair because we're solving for where these two equations intersect or meet. All right, let's do number 2 together. We have to write it down. Oh, but there's another wrinkle in here. We need to solve for y. So I'm going to give myself some space underneath. Here's the second equation they give us. Okay, so number 2 on page 133. We need to get y by itself, but we want it to be positive y. So let's move the x squared and the 3x over to the other side. So y equals, take away x squared to both sides, take away 3x. Okay, that's one equation. We want to leave the y alone. Y equals, we're going to take away 2x to both sides. These are not friends. They don't multiply together. Equation 2, equation 1. We go to our calculator. We go to y equals. We press clear. Again, any directions you need to write down, these are your notes. You write them down. You are responsible for your education. Negative x squared minus 3x. Clear that out. Negative 2x plus 5. Press graph. Oh no, they don't intersect. What's the graph say? Sorry, what do the pictures say on page 132? No solution. And that's your answer. All right, number 3. Write it down. And I didn't give myself enough room. My notes are very messy. But that's okay, because I'm going to pause the ed puzzle right now. You're going to answer what y equals for the first equation. And then you're going to come back and you're going to see the work to make sure you're correct. So y is going to go over here. Negative 2, we're going to add it over there. So we added y to this side. We added 2 to this side. We're going to leave y alone. We're going to take away x squared from both sides. That stays a positive 2. Here's my 2 equations. We go to the calculator. We go to y equals. We clear it out. We type our first one in. We go to our second equation by hitting the down button. We type our second one in. Ooh, it looks like it intersects in 2 spaces. Great. I'll find this one with you. You're going to find this one on your own and answer it in the ed puzzle in a little bit. Second trace. Go down to number 5. It asks you for your first curve. Now listen, it doesn't really matter where the cursor is. Is it pointing to the first curve? Honestly, you're always going to hit enter because you're only going to keep 2 curves in at the same time. Second curve, it automatically jumped to it. You just hit enter. Now we're going to take a guess. I'm going to move to the left to help you find this one. Okay, now you are definitely not allowed to write these numbers down as decimals. So the first coordinate, I'll take mixed numbers, -1 and 1/3. And well, anytime a number is repeating, it's over 9. So this is 2/9. -1 and 1/3 and 2/9. -1 and 1/3. Now this is just 2 over 9. If it was a 4 repeating, it's 4 over 9. If it's a 6 repeating, it's 6 over 9, which simplifies to 2/3. Okay, over 9. All right, I found one of them. Okay, let's actually make this look better. 3 times 1 is 1, plus 1 is 4. This is -4/3, comma 2/9. Okay, here's one answer. There is a second answer. You're going to do the same steps again, but you're going to move that guess to the right over here. So go ahead and find that, enter it in the ed puzzle. All right, now we're on to circles. So go ahead and copy down page 134. Copy down the pictures. Same idea. If a line doesn't intersect the circle, guess what? No solution. If a line touches the circle at 1 point, 1 solution. If a line touches the circle at 2 points, 2 solutions. That's it. Okay. But circles are fun because we will always have to solve for y. So you're going to write your 2 equations side by side. This is number 4 at the bottom of page 134. Obviously, you paused the video. So if you didn't pause the video yet to copy those pictures down, now's the time so that when you come back, we pick up where you left off. You can't plug anything to your calculator. It looks like this. You need y to be by itself. So what are we going to do? We're going to take away x squared from both sides. But x squared is not friends with 16. So we just write y squared equals negative x squared plus 16. How do you get a square by, or sorry, how do you undo a square? We square root it. Anytime we square root it, don't forget, we need that plus or minus. Then you go ahead and you write out negative x squared plus 16. Don't worry that this is a negative. It doesn't matter because we don't know what x is. The calculator is going to figure that one out. And this is already solved for y, so we're good. Here's the thing, though. Your y1 is going to be positive the square root of x squared plus 16. You can't tell your calculator or. It doesn't understand or. Well, this is plus or minus rad negative x squared plus 16. So in y1, you're going to plug in that. In y2, you're going to plug in the negative version of that. And then in y3, we're going to plug in this equation. Okay. So let's try it out. We go to y1. Sorry, we go to y equals. I'm going to already clear this out. In y1, we plug in the square root. Now, if your calculator opens with a parenthesis, you better close that parenthesis later. Make sure you're using the correct buttons here. I don't have parentheses, so I don't need to close parentheses. But if you have a TI-83 plus, that's when you close your parenthesis. Some TI-84s as well. Down here, we start with a negative. Make sure you type in the correct button. Negative x squared plus 16. And then down here, negative x plus 4. So y1, y2, and y3. Now we have 3 things. First curve, second curve matters. We go to the graph. It's not great using circles here, but this is supposed to be a circle. Oh, and there you go. It intersects at 2 points. We're probably not going to find this one, but this one right here. Second trace, intersect. Okay. Our first curve, it tells us, is our first curve positive rad negative x squared plus 16? Yes. And if you're not sure, you can go to the right just to see, okay, I want to be on this curve. I want to find where these 2 curves intersect. I don't know. I'm looking for this intersection. I don't need this curve down here, this bottom part of the circle. So hit enter. Second curve. Is this my second curve? Is this the line that I want to find out where it intersects with the top part of the circle? Oops, I just undid it. Let's do it again. I pressed the button by accident. Second trace. Here's my first curve. The question is this my second curve? No. This is my second curve. Press the up button. Oh, sorry. Press the down button. The down button to go to y3, your line. Now my cursor is on the line. I am looking for this top part of the circle and the line intersect. So I need to identify the line as my second curve. Hit enter. And now I want to take a guess. And the intersection here, ooh, there's that e to the negative. So one answer is 0, 4. Now the other answer, I don't know if it's going to do it, but let's find out. We're going to second trace, intersect. But my first curve, I don't want it to be the positive one, although it would work. I want it to be the negative one. So I hit the down button to go to y2. This is my first curve. I want this and the line. Enter. Second curve, it automatically went to the line. See, it says it right there. It tells you what it's on, the line. And now Let's take a guess. I don't know if it's going to work just because it's in that area where it doesn't look like it knows how to compute a circle, but it looks like it intersects somewhere around here. And I'm going to hit, yeah, it didn't work. Bad guess. All right, so let's look at it, children. This is a circle. It's centered at the origin. We already know it goes through 0, 4. What do you think it goes through right here? If this is 4 units up, it's got to go through 4 units to the right. Okay. So the other one is 4, 0. Your calculator, at least my calculator, some of the more advanced ones probably can do it. My calculator, it doesn't really work right here at the x-axis. All right. But then think about it. What happens when you plug in 4? Negative 4 plus 4 is 0. What happens when you plug in 4? 4 squared is 16. Negative 16 plus 16 is 0. The square root of 0 is 0. It works for, and it'll work for this one too, because negative 0 is 0. It works for all of them. If it works for all of them, it's a solution. All right, this video is running long, but that's okay. So we're going to do one more. Number 5. Another circle and a line. We need to get y squared by itself. So we're going to take away x squared from both sides. We have to square root both sides. So we get y equals plus or minus rad negative x squared plus 4. There's going to be a pattern, by the way. So here's our y1, here's our y2, here's our y3. We'll go to our calculator. Sorry about that. Clear it out, and clear it out. Number 5. So first, positive negative x squared plus 4. Down here, negative square root of negative x squared, right? This is this, plus 4. And finally, x plus 4. Now, remember, if I'm going too fast, children, you are pausing. This is your video to watch. Here's a little circle. Oh, it doesn't even intersect. No solution, right? It's not intersecting. We're looking for where these two curves or lines or whatever equations intersect. No solution. All right. At this point, it's just practice with your calculator. You can see you're letting your calculator do the work for this. So you're going to have problems to do so that you can get proficient. If you're at home, you're doing this with an emulator so that you can use it when you come to class. You can use the graphing calculator when you come to class.